Elementary, my dear Einstein. Chapter 10. A Tale of Two Theories. The establishment of a proper theory typically starts with observation of a pattern. Consistency of a pattern may prompt a hypothesis as to how this pattern occurs and predict the next thing that will happen. If in practice the next thing doesn't happen as predicted, the theory will have failed. If the outcome cannot be repeated by other observers, the theory will have failed. If a less convoluted explanation provides better predictions, the theory will have failed. The explanation with the least number of assumptions and variables has the best chance to survive. This is a scientific method. It leans on Occam's razor that predicts the simplest explanation is usually the correct one. There is another type of theory. It is derived from a Latin word ad hoc. It means special, or in this case. The best way to understand the purpose of an ad hoc theory is by analogy. A man returns home early and finds his wife scantily dressed in the kitchen with a neighbor in attendance, wearing only his jockstrap. The husband forms a theory in his mind that something evil is afoot. Now let's say the wife explained. She was drowning in the swimming pool and called for help. The neighbor jumped the wall, ripped off his clothes, and rescued her from peril. This is what we call an ad hoc theory. Of course, we actually call it, "Do you think I'm stupid?" But in science, it's called an ad hoc theory, or a special theory. It attempts to restore faith in the status quo, despite new evidence to discredit the initial understanding of a pattern, theory, or evidence. Depending on how much the husband wants to believe that he is happily married to a loving wife, he may place his faith in the ad hoc theory too. One prediction of the special theory is that he will never see the neighbor half-dressed in his kitchen again. As this is a very favorable outcome, he may adopt the ad hoc theory. Scientists are much like the husband. They make an observation and adopt their theory to fit the evidence. But the institution of science is more like the wife. It prefers holding on to the status quo. It will offer every fanciful explanation thinkable. It will attempt to convince the husband that drowning and getting rescued every afternoon is more plausible than suspecting her of conniving behind his back. In the case of Airy's experiment on the aberration of starlight, a conflict arose between the results of the scientific revolution and the results of the scientific method. The scientific revolution convinces us that the Earth orbits the Sun. The scientific method refused to support these claims. If Earth is stationary as showed by the evidence, it cannot be in orbit. What science needed was an ad hoc theory to explain away the evidence, because the alternative is philosophically impossible. Sherlock Holmes stated it thus: whenever the impossible has been eliminated, whatever remains, no matter how improbable, must be true. Scientists set out to find, however improbable, any explanation that will save the scientific revolution by disproving the results of Airy's experiment. It was not easy. For the next 24 years, the heliocentric model was like a whale in the desert, gasping for subsistence, having nothing to support it. It had received a mortal blow, dead as a doornail. But then a man came up with a solution to the problem. Hendrik Antoine Lorentz recalled work done by Augustin Jean Fresnel in 1818. Fresnel noticed movement of liquids form eddy currents, and eddies make visible shadows, indicating its optical effects. This can be seen in the bathroom when hot water is added. Lorentz enlisted Fresnel's observation to concoct an ad hoc theory to save the dead idea of Copernicus. He reasoned that since we know there is an ether, and we assume Earth is moving, then Earth dragging through the vacuum of space containing the ether may cause a turbulence, a drift in the ether that has optical effects. It may make the ellipse observed by George Biddle Airy bigger or smaller or larger in winter, or smaller in summer, or just generally chaotic, as is the nature of turbulence. But Lorentz further imagined it just so happened that the chaotic turbulence of the ether could be blamed for hiding the 50% increase in the size of the ellipse that Airy failed to observe. By this masterful logic, we can believe the experiment showed Earth to be in orbit without showing Earth to be in orbit. The collection of assumptions is quite remarkable. Nobody has ever shown any similarity between properties of water and properties of a vacuum. Yet we assume these are sufficiently similar to form the foundation of an ad hoc theory acceptable to science. Anybody tempted to criticize this ad hoc theory was faced with a simple question. If not blaming ether drift for the bad news, what would you blame? How do you explain away the evidence? Ether drift became the official explanation of science. At the time, nobody had any doubt in the existence of the ether, and the ether was absolutely necessary to obfuscate the obvious. But note the circular reasoning here. We assume Earth is moving. We assume movement of Earth caused turbulence of the ether. We assume ether drift negates the observation. Having abolished Airy's proof of a stationary Earth, we may again proceed to orbit. The scientific revolution was saved by the imagination of Hendrik Antoon Lorentz. The man returning from work every day, finding his wife and a neighbor in the kitchen, has adopted the special theory of relations. Sherlock Holmes was still flowing from the pen of Sir Arthur Conan Doyle at the time of this atrocious application of his principle. Had Sir Arthur deployed such stupendous improbabilities in his fiction, nobody would have bought his books. But when science spins these incredulities, we hang on the lips of gods. By continuing the pretense that science was conducted, the dead whale of a theory was placed on life support. It never swam again and would soon die, but that did not stop science from flogging its corpse for some time to come. During this time, no books had to be unwritten, no PhDs were cancelled, and the most magnificent of all the gods sat perched on his fiery stool at the center of the universe. By rejecting Airy's experiment, science was again stuck with theories of relativity. Geometrically identical models, some aligning better to Scripture, some to Pythagoras. In the meantime, James Clerk Maxwell had brought together the known facts on all the theories, including observations on electricity and magnetism, and formulated what became known as Maxwell's equations. He demonstrated that light is an electromagnetic phenomenon. Radiation, such as light, consists of energy, which constantly switches between electric and magnetic waves, reacting with the ether. His theory made predictions that could be tested to support or falsify it. One of these predictions was the existence and usefulness of radio waves and X-rays. These were soon discovered to confirm his theory. Maxwell anticipated light to become a useful instrument for measuring absolute station or motion. Science was inching forward, approaching the holy grail of light, for the properties of light would soon disclose a very inconvenient truth.